Hi everyone, in this video we solve problem 1.5 from the book Applied Thermodynamics Mechanical Disturb. Here is the statement. The problem 5 from chapter 1. A fluid at 0.7 bar occupying 0.09 meter cube is compressed reversibly to a pressure of 3.5 bar according to a law PV. The power n is equal to constant. This n is in the power, not with not the subscript of volume V. Then the fluid is then heated reversibly at a constant volume until the pressure is 4 bar. The specific volume is then 0.5 meter cube per kg. A reversible expansion according to a law PV to the power 2 is equal to constant restores the fluid to its initial state. Sketch the cycle on a PV diagram and calculate the mass of the fluid present, the value of n in the first process, the network of the cycle. So let me draw first the PV diagrams so you can clearly understand each step when I am solving the problem. That's why first I am focusing on the PV diagram. So pressure P1, that is 0.7 bar, means to say 0.7 multiplied 10 to the power 5 Newton per meter square. Then the volume, total volume at point 1, that is V1, it is 0.09 meter cube. That is given. This is, let's say, volume V1. This point is our first point V1. The PV diagram is compressed reversibly to a pressure of 3.5 bar. The next pressure after compression is obtained, that is 3.5 bar, means to say 3.5 multiplied 10 to the power 5 Newton per meter, and it followed the law PVN is equal to constant. So from this process 1 to 2 follow the law PVN is equal to. So from 1 to 2, here I am writing the PV diagram from process 1 to 2. The volume here is V1, and the volume is, this is specific volume V2, this is also specific volume V1. Here the pressure is V2. During compressions, so compression is taken place by the law PVN is equal to constant from 1 to 2. In the same time pressure increases and volume decreases. Now what next it says, the fluid is then heated reversibly at a constant volume until the pressure is 4 bar. So next the pressure that reached to P3 and it is 4 bar, means to say 4 multiplied 10 to the power 5 Newton per meter square. It means that the process 2 to 3 is taken place under constant volume. So I will draw its vertical to this line because here the volume is constant, so V2 and V3 will be the same. So this is pressure. The volume V2 must be same with volume, specific volume V3. So the specific volume of V2 and V3 is the same because this process 2 to 3 is taken place at a constant volume. That's why this is the main reason. What next it says, so after that a reversible expansion according to a law EV square constant restored the fluid to its initial conditions. Then what happened? Then expansion is taken place until it's reached to its initial condition. So from our process 3 to 1, this is expansion process and it followed the law PV square is equal to constant. So here I can say that from process 3 to 1, it followed the law PV square is equal to constant. I hope you understand the statement and how I draw each step on the PV diagram. If you understand it in this way, believe me, you can solve any kind of questions in exam. I hope you have cleared your concept. If you're still in confusion, you can ask. Find the mass of the fluid. Just focus on the process 3 to 1. Here the expansion is taken place by the lab PV square is equal to constant. So I can say that P1 V1 specific volume at V1 must be equal to V specific volume. This is specific volume, remember, square. Simplifying this equation for specific volume V1, specific volume is then, remember, the specific volume V2 and V3 is given and it is 0.5 meter cube per kg. Here you can see in the statement. So just in terms of V3 write 0.5. Now solve this on calculator. You will get the specific volume V1. Take square root both sides. Now it is very easy. The mass formula is equal to total volume divided by specific volume. So total volume at point 1 is given. Specific volume has been determined now. Now just put in this formula V1, that is 0.09 divided by specific volume 1.195. After solving you will get mass of this cyclic process, that is 0.0753 kg. So this is our first requirement of this statement has been solved. Next is to find the value of n in the first process. Put the values of V1 and specific volume of V1, V2 and pressure P2 in this formula. Specific volume V1, specific volume V2 0.5. After simplifications, so upon simplification you will get 2.39. The power n is equal to 5. (1.847). This is our second part. So in that case the work done from process 1 to 2 is equal to m the work done on the system 1 to 2. It is 8121 joule or 8121 Newton meter. Now work done from process 2 to 3 is equal to pressure and then change in volume. So the change volume is constant, so there is no change in volume. So it means that from process 2 to 3 the work done in the system is 0. Now from process 3 to 1, 3 to 1, it followed the law PV is equal to PV square is equal to constant. Now the same formula will be used, just the n value will change and the corresponding P1 V1 and P3 V3 value. So here I can say M P1 V1 minus P3 V3 divided by n minus 1 values is minus 8761 joule or Newton meter, whichever unit you prefer you can use. Next is to find the net work of the cycle, and that was our final requirement. It will be equal to work from process 1 to 2, work from process 2 to 3 we get, and work from process 3 to 1 you obtain. Just write its value and add them. From 1 to 2 it was 8121 plus 2 to 3 it was 0, then 3 to 1 it was minus 8761. After solving this value you will get the net work of the cycle, that is minus 640 Newton meter, and this is our final answer. I hope you understand. If you stand in confusion you can ask in the comment section. This negative sign means that work is done by the systems.